Hello dear students, I am Prema Halegaud, serving as Assistant Professor. I heartily welcome you all to this video class of B.Sc program of Physics subject. In the 5th semester syllabus described by Davangere University in the 5th paper, that is Atomic Physics and Laser, I am going to deal with the 3rd module, that is laser. So in our first session, I will discuss about stimulated absorption, spontaneous emission, stimulated emission, and also the difference between spontaneous and stimulated emission. Learning objectives of this session is to create interest to know more about the laser and also to understand the basics of laser action. After this session, the student will know about the history of laser and they will understand the basic concepts which will help to understand the working of laser. The laser, these have many applications in many fields like medical, entertainment, research, industry, defense and etc. Those we will discuss in our 12th session. The word laser is the abbreviation of light amplification by stimulated emission of radiation. The theoretical basis for the development of laser was provided by the scientist Albert Einstein in the year 1917. In the year 1960, the first laser device was developed by the scientist Th. Maimon. Stimulated absorption. We all are familiar with the energy level diagram of an atom. In the diagram, at the center there is nucleus and around the nucleus electron revolves in particular paths and these paths are called as energy levels. Let us consider two energy levels E1 and E2 of the ground state and excited state respectively. Suppose a photon of energy E2 minus E1 is equal to h nu interacts with an atom present in the ground state. The atom gets excitation from the ground state E1 to the excited state E2. This process it is called as stimulated absorption. The stimulated absorption rate it depends upon the number of atoms available in the ground state and also it depends on the energy density of photons. The stimulated absorption rate is directly proportional to the number of atoms in the ground state and also directly proportional to the density of photons. Spontaneous emission. Let us consider two energy levels E1 and E2 of ground state and excited state respectively. Now consider the atom which is already in the excited state. The excited atom does not stay a long time in the excited state because excited state is highly unstable. The excited atom gets de-excitation after its lifetime by emitting a photon of energy E2 minus E1 is equal to h nu and this process it is called as spontaneous emission. The spontaneous emission rate it depends upon the number of atoms present in the excited state and here the spontaneous emission rate is directly proportional to the number of atoms present in the excited state. Stimulated emission. Again let us consider E1 and E2 energy levels of ground state and excited state. Let a photon of energy E2 minus E1 is equal to h nu interacts with the excited atom in their lifetime. The atom gets de-excitation to the ground state by emitting of another photon. And now we have two photons and these two photons have the same phase and they follow the coherence. And this phenomenon it is called as stimulated emission. The stimulated emission rate it depends upon the number of atoms available in the excited state and also energy density of photons. Here, the stimulated emission rate is directly proportional to the number of atoms in the excited state and also is directly proportional to the density of photons. Now let us discuss about the difference between the spontaneous and stimulated emission. First one, the spontaneous emission was postulated by the scientist Niels Bohr. The stimulated emission was postulated by the scientist Albert Einstein. Second one, the additional photons are not required in spontaneous emission. Additional photons are required in stimulated emission. Third one photon is emitted in spontaneous emission and 2 photons are emitted in stimulated emission. Fourth one, in spontaneous emission, the emitted radiation is polymonochromatic. In stimulated emission, the emitted radiation is monochromatic. Fifth one, in spontaneous emission, the emitted radiation is incoherent. In stimulated emission, the emitted radiation is coherent. Sixth one, in spontaneous emission, the emitted radiation is less intense. In stimulated emission, the emitted radiation is high intense. Seventh one, the emitted radiation have less directionality in spontaneous emission. For example, light from sodium or mercury lamp. In case of stimulated emission, the emitted radiations have high directionality. For example, light from laser source. Now let us discuss some multiple choice questions. Which scientist first came up with the idea of stimulated emission? A. Alexander Graham Bell. B. Niels Bohr. C. Arthur Shallow. D. Albert Einstein. Answer is D. Albert Einstein. Second one, what is the full form of laser? A. Light absorbent and stimulated emission of radiations. B. Light absorbing solar energy resource. C. Light amplification by stimulated emission of radiations. D. Light amplification of singular emission of radiations. Answer is C. Laser is a short form of light amplification by stimulated emission of radiations. Stimulated emission is the process by which amplification of radiations takes place, and hence the meaning of laser that the light is amplified by stimulating the emission of radiations. Third one, in stimulated absorption, what is the lifetime of atoms in the ground state? A. 1 second. B. 1 minute. C. 1 hour. D. Infinity. Answer is D. At the ground state, the atoms are perfectly stable. They are under no excessive force that might lead to become unstable. All the forces are balanced. Thus, as the atom is stable in the ground state, its lifetime is infinity. Fourth one, photons are A. Quanta of energy. B. Quanta of light waves. C. Quanta of sound waves. D. Quanta of heat. Answer is quanta of energy, A. Fifth one, which process gives the laser its special properties? A. Dispersion. B. Stimulated absorption. C. Spontaneous emission. D. Stimulated emission. Answer is D. Stimulated emission. And for this session, I refer book Lasers and Nonlinear Optics by B.B. Lord and also eSource. Thank you.